The station hosts a collaborative experiment that has been operating on station for more than 5 years. And while the French Space Agency is the lead for this experiment, it involves American investigators and scientists from many other countries. DCLIC continues to send back data allowing us to learn how various materials change from solid to liquid to gas and then back again on the molecular level. The microgravity environment in space allows investigators to study fluid processes that are difficult and sometimes impossible to observe here on Earth. Tracy McMahon, a public affairs officer with the station's Payload Operations Integration Center there at the Marshall Space Flight Center in Huntsville, Alabama, spoke recently with DCLIC's mission manager from the French Space Agency.
The name of the experiment is DCLIC. It stands for Device for the Study of Critical Liquids and Crystallization. DCLIC is a facility dedicated to the study of transparent media. It's a kind of furnace in which one can put the media he wants to study. For example, we have studies on supercritical fluids or solidification of transparent media. It is on board the space station since 2009 and working since then. A typical simple material that is being studied on board DCLIC is the water. And we are studying water as a critical fluid because when you heat water at a very high temperature, which is close to 400 degrees C, it becomes supercritical, which is a kind of mix between the fluid and gas state. It's a kind of gas that weighs like a fluid. And when you perform that kind of study on the ground, it is very difficult because as it is a gas that weighs like a fluid, it is highly compressive and you cannot have a whole cell which is in a supercritical state, for example. And under microgravity, as there is no weight, you can have a whole cell of supercritical fluid and you can study it very precisely. And for example, the measurement of the critical temperature of water that we perform on board DCLIC is the most precise ever measurement of this temperature. When you are above the critical temperature, the water is able to break the hydrocarbonic chains of materials. And so you see that you can recycle material by injecting material into supercritical water. The main application for this is to help recycling organic media, which is basically waste, during long duration manned missions. So this is one of the applications of DCLIC, but there are several others, like solidification studies, for example. The objectives of performing that kind of experiment in microgravity is to get rid of gravity, of course, because when you have gravity, you have induced phenomena like convection, for example, that can hide some of the phenomena that occur in solidification, for example. The ISS is the right place for our experiments for three main reasons. The first is that it gives us access to long-duration microgravity, which is really needed for our applications. The second reason is that we are able to launch and return hardware from and to the International Space Station and to refurbish this hardware. And so we have access to multiple experiments with only one payload. And the third reason is that on board the ISS we can store several experiments, several inserts that are exchanged inside DCLIC. For the time being, we have three inserts that have been developed with DCLIC. For each insert, we have a team of scientists, and in each team, we have both American and French scientists. So, for example, for the high temperature insert dedicated to the supercritical water studies, we have scientists from Glenn Research Center in Cleveland, Ohio, and when the French scientists are located in Bordeaux, in France. We have developed some tools that give the scientists the opportunity to follow in real time the experiments from their labs. They only need an internet browser and they connect to a web server and they see in real time the evolution of the experiments, the parameters and the images and so on.
More information on DCLIC can be found on the French Space Agency website at cnes.fr and search for DCLIC, D-E-C-L-I-C. If you're not fluent in French, you can click on the British flag in the upper right-hand corner to get the English version from that website.